I greet you all. Your math crusher today is Chimela Webster. We are gonna look at indices and surds. So straight away, as we looked at logarithms some time back, also indices have laws governing them. The first law here, observe it clearly. If I'm multiplying numbers of the same bases, I just pick one base, then I add the powers, that's b plus c. Then if I'm dividing numbers of the same bases, I just pick one base, then I subtract the powers as you're seeing there. Then the third law, if I'm dividing, let's say if I'm having a fraction like 1 out of a to power b, and I don't want a fraction in it, it's just simply to a power negative b. Then if, let's say I'm having a given number a to power a given constant, say b, again the whole of that to power another constant, say c, I just simply multiply the powers and I come up with a to power bc. Then also here, let's say if I'm equating numbers of the same bases here, I just simply equate the powers. Those are the sum of simple laws that are governing what? That are governing indices. Therefore, straight away, we are gonna look at some examples here. I managed to come up with this example: 2 power 2x plus 8 minus 32 into bracket 2 power x plus 1 is equivalent to a 0. Then I think after me solving the whole of this, you will be able to solve these unable questions here. Straight away, if you observe this example clearly, it's 2 power 2x plus an 8, then minus 32 bracket 2 power x is plus 1, it's equivalent to a 0. Then if you observe this, it's like initially it was having 2 power 2x times 2 power 8. This one comes from the first law here, which I informed you. It's like when I'm multiplying numbers of the same bases, I pick one base, a 2, then I add the powers 2x plus 8. Then this is minus 32 into 2 power x plus a 1 equivalent to a 0. I think that is clear. Therefore, this one is the same as having 2 power x. Then if I square it, same law here. If I'm having a power b, any, the whole of it power c, I just simply multiply the powers. It's what I've done here. Then times 2 power 8, which is 256. Then this is minus 32 into 2 power x plus 1, simply equating to a 0. Then I can let 2 power x be a given constant, say y. It means that now here, remember you said the 2 power x, it's a given constant y. It means that is y squared. Then y squared times 256, that's 256 y squared minus 2 power x is y, that's 32 y plus a 1 equivalent to a 0. Now, this is a quadratic equation of which you have to solve it quadratically. Then, from there, by solving it quadratically, you come up with the factor as positive 16, but we reverse it and it becomes 256 y squared. Then if it is positive, you just change it here, minus 16y. It is only one factor, again minus 16y minus 1 equivalent to a 0. Then Here, what we do, we factorize, and the common factor here, it is 16y. Here, 16y remains minus 1. Then here, the common factor is negative 1. 16y remains minus to a 1 equivalent to 0. Then these brackets are the same. Therefore, it means that 16y minus 1 is equivalent to a 0. Then we conclude by y equivalent to 1 out of 16. I think that is clear. Then remember, you said that 2 power x is equivalent to a y. But y is 1 out of 16. It means 2 power x is equivalent to 1 out of 16. Then 2 power x will be equivalent to 1 over 16 is the same as 2 power 4, isn't it? Therefore, this one, if I want to remove a fraction in it, it's just 2 power x is equivalent to 2 power negative 4. Remember, one of the laws I said that if I'm equating numbers of the same bases, I just simply equate the powers. It means that is x equivalent to negative 4. That one becomes the answer. Therefore, from there, I think you will be able to solve those numbers. From there, let's go straight away to surds from here. Surds also have laws. If surds, how I can define them, they are just irrational figures which do not have exact values. For instance, root 2, root 3, and so forth. Therefore, also, they have got some laws. If I'm adding surds with the same roots here, root b, I just simply add the coefficients a plus b. If I'm subtracting also, I just simply subtract the coefficients and I retain a similar root. Then if I'm multiplying surds, for instance, root 2 times root 2, for this case I've used root a times root a, I just get root a squared, which is an a. Then if I'm multiplying surds with different constants in the roots, I just simply retain the square root symbol and I multiply the constants there, which is a times b. Then here we are going to try out these examples here. Then I think you will be able to work out those examples in the exercise that I've put here. Then the first, they are saying that they are saying simplify. We are having root 12 plus 5 root 3. Now here, how am I going to simplify? Root 12, you get two numbers, one having a root, then the other when it's missing out a root, but when you multiply them, you get 12. That's root, get 4 times 3, plus 5 root 3. Here, 4 has a root, 3 doesn't have. 4, its root is 2. Therefore, becomes 2 root 3 plus 5 root 3. When I'm adding surds with the same roots, I simply just add the coefficients, which is 2 and 5. 2 plus 5, you get 7 root 3. I think that is clear. Then, another example here, it was all about root 5 having root 5 plus root 3 over root 5 minus root 3. Here, what we are just going to do is just rationalizing. When rationalizing, you multiply the denominator up and down, but with a changed symbol here. If it's a negative, it becomes positive. If it's a positive, it becomes negative. Therefore, here, having root 5 plus root 3 over, this is root 5 minus root 3. I multiply the denominator up and down, but with a changed symbol here, over root 5 plus a root 3. I think that is clear. Then, if you observe down here, this is difference of two squares. These two difference of two squares, and here is just if I multiply this and this, it's like having root 5 plus root 3, the whole of it squared. It means root 5 plus root 3, the whole of it squared, over, if this is difference of two squares, it means it's having root 5 squared minus root 3 squared. If I square this is root 2. If you expand this using binomial expansion, you come up with root 5 squared, which is 5, plus root 3 squared, which is 3, then plus a 2 root 5 times a 3 over root 5 squared, that is 5 minus root 3 squared, that's 3, 5 minus 3, which is a 2. Then 5 plus a 3, that's 8, 8 plus 2 root 15 over a 2. This 2 can cancel out with the whole of this. I retain a 4 plus root 15. I think that is clear. Then another example here, it was all about, that is example 3, root 2x plus 3 minus root x plus 1 is equivalent to root x minus a 2. I think from here, let me first of all transfer this negative root 2x plus 1 to that side, come up with 2x plus 3 square root is equivalent to root x minus 2 plus root x plus 1. Then to eliminate this, I square both sides. This square cancels out with the root. I retain 2x plus 3 equivalent to expand this using binomial expansion. I get root 2x minus 2 squared, which is x minus 2, plus root 2x plus 1 squared, which is x plus 1, then plus 2 this times that, which is 2 root 2. If I multiply this times that, I get x squared minus x, then minus a 2. I think that is clear. Then x plus x, that's 2x. If it comes this side, it becomes negative 2x. The whole of that becomes a 0. Then negative 2 plus 1, that's negative 1. If it comes this side, it becomes positive 1. I retain a 4 equivalent to 2 root 2 x squared minus x minus 2. Then to remove this root symbol, I square both sides, come up with 16 equivalent to 4 into bracket x squared minus x minus a 2. I think that is clear. Then if I divide this route by a 4, I remain with a 4 equivalent to x squared minus x minus a 2. Then this one, the same as having x squared minus x, 4 going this side, it becomes negative 4, which is negative 6, equivalent to a 0. If you solve this is a quadratic equation. Solving it, you come up with x equivalent to a 3 or x equivalent to negative 2. But remember, they informed us to prove our answer. And from there, the expression which was given was root 2x plus a 3 minus root 2x plus 1 equivalent to root 2x minus 2. Then from here, if x is a 3, I substitute a 3 here, come up with 2 times 3, that is 6, plus a 3, which is 9. Root 9, it becomes 3 minus 3 plus 1, that's a 4, root 4, 2, equivalent to x minus 2, 3 minus a 2, that's a 1, root 1, which is a 1, 3 minus 2, 1 equivalent to 1, which is 2. It means that x is a 3. Now we can also prove out if x is a negative 2, substituting it here. Negative 2 times 2, that's negative 4, plus 3, that's root of negative 1, minus x plus 1, negative 2, plus 1, that's negative 1. Root of negative 1, equivalent to x minus 2, negative 2 minus 2, that's root of negative 4. Here, I just subtract the coefficients. 1 minus 1, which is 0, something like 0 root something, which is a 0. Is it equivalent to root of negative 4? This is false. Therefore, we conclude by saying x is a 3. Therefore, from there, you will be able to practice out those numbers there about surds. Stay blessed. I remain Chimela Webster.